Welcome, everybody. Good afternoon or good morning if you're joining us from the West Coast, and welcome to this 7th event in our Outcomes Estimation Tools Training webinar series. This time we're featuring Prioritize, Target, Measure, Application, or the PTMApp tool, and Drew Kessler. Thank you all for being here today. I'm Michelle Perez, the Water Initiative Director for American Farmland Trust, and I'm joined by my colleague, research scientist Jen Tillman. Unfortunately, Aisha Tapp-Ross hopes you're all doing well, and she'll join us for our December webinar. For those of you who don't know, American Farmland Trust is a national nonprofit founded in 1980. Our mission is to save the land that sustains us by 1, protecting farmland, 2, promoting environmentally sound farming practices, and 3, keeping farmers on the land and preparing for the next generation of farmers. For today's webinar, after a few reminders and a quick poll to see who's in the room, we're going to hear from Drew Kessler about PTMApp. Drew will first lead us in a presentation and then a demonstration of the tool, and we've reserved the last 20 minutes of this webinar for Q&A. And I also wanted to thank our funders, the EPA Office of Water, the Walton Family Foundation, and the Mosaic Foundation for making this webinar series possible. So for some quick housekeeping reminders, we're using Zoom. So you as attendees will have your camera and microphones turned off throughout the event. You can use the Q&A feature at the bottom of the screen at any time to ask questions, and the speakers will answer the questions during the last 20 minutes of the event. You can use your name or be anonymous when asking those questions or making comments, and you can vote up questions that you want to be prioritized. If you're having technical difficulties, direct message me or Jen, and we'll try to help you. After each webinar, you'll expect to see an email from us 3 to 4 days later, so usually the Monday following the Wednesday webinar, that will provide you with recording and the slides from the presentation, as well as any other information about the next month's speakers. And by the following Monday, we will post the recording to the webinar registration page, which we welcome you to share with your colleagues and friends that may be interested in viewing. And Jen's going to post that webinar page in the chat now. So in a moment, I'll be sharing a link to an 8-question anonymous evaluation survey that should take you about 2 minutes to complete. The survey will pop up when you leave, but you can also click on it now so it opens up in a new browser. And we ask that you complete the survey right after the event ends, and that gets you the chance to be entered into a drawing today for a $25 Visa gift card. If you do so before 6 p.m. Eastern time, we're so excited to share that incentive with you, which we started last month, and we're looking forward to greater evaluation efforts because we really care about what you think and feel about these webinars, and we use your feedback to inform the next month's speaker or make changes to this webinar series. Thank you, Jen, for sharing that link. So now time for polls. Let's see who's in the room. We have 3 quick poll questions that hopefully will come across your screen any second now. Are they working, or maybe I'm just not seeing them? There we go. All right, so which one first best reflects your occupation? Are you a member of the government service network? There's some examples of federal and state and local agencies. Are you part of non-government organizations, federal farm trade associations, environmental groups? Are you an academic, an extension, a university, a corporation, environmental market developer, or other? Thank you so much for participating. Second question, if there's only 4 types of audience members, which best describes you? A developer of outcomes tools, methods, or models, a current user of these outcomes estimation tools, methods, or models, a potential future user of outcomes estimation tools, methods, or models, or a person simply interested in learning about environmental estimation tools and issues. Thank you. And third, what is your experience level with this particular tool, PTMApp? Had not heard of it, have heard of it but never used it, heard of it and used it. I refer to it often. And we'll give you just a few more moments to respond to that and let us know who you are. Thank you so much for participating. Don't be shy. Tell us who you are. Thank you so much. I see some participation going on. Thank you so much. All right, Jen, why don't we end the poll now? All right. And you'll show the results soon? Great. All right, majority of you are in the government service agencies sector, 75%, followed by NGOs. We have a few corporations or environmental markets developers and other. Cool. So most of you are current users and potential future users of these tools, also the developers, and some of you are simply interested in learning more. Most of you had not heard of PTMAP and you've heard of it but not used it. And a few of you refer to it often. Awesome. And the developers Drew's not allowed to answer the question, just to let you know. All right, great. And now I'll move on to my final slide before I turn it over to Drew. So this is the registration site that this is what you'll see there that Jen is sharing in the chat. And you'll see this webinar schedule and links to the recording, including the most recent October 4th EPA pollution load estimation tool or PLET presentation. And you'll see that next month on December 6th, we'll be hosting our very own Ellen Yateman, who's going to be training on AFT's soil health economic calculator tool. We hope you join that event. All right, without much further ado, I'm going to stop sharing my screen and turn it over to Drew. Welcome, Drew.
Thank you very much, Michelle, and thank you to American Farmland Trust for the invitation to be a part of this. I'm going to start working on getting my screen share going. It'll take me just a minute to get synced up. We did test this, so hopefully it works as well as it did while we were testing. All right, I believe everyone should be seeing my title slide.
Yep.
And I'm going to jump right into stuff. So I'm going to move to introductions. And as I go through mine, I'm going to invite Uday Singh, who is shown in the bottom right corner, to come off of mute and show his video, because I'm going to give him the floor to do a brief introduction after I'm done. So my background, I work with Houston Engineering, been there for about 10 years. I lead our company's environmental sector, and I've kind of been involved with this tool PTMApp since it started being developed in about 2014, 2015. You see a little bit of information about me on the slides there, and with that, I'll kick it over to Uday if he'd like to introduce himself briefly as well too.
Well, greetings, everyone. I think I still don't have my video on, but I hope you guys can hear me.
Yes, we can.
Okay. Well, good morning, everyone. Uday Singh. I'm the modeling and outcomes coordinator for the Minnesota Board of Water and Soil Resources. I've just joined this job 3 months ago, but my background, I'm an agriculture engineer with a 5 years degree from India, and then a master degree in water resources and irrigation and drainage from Asian Institute of Technology, Bangkok, Thailand, and then a second master and a PhD in civil and environmental engineering from Texas Tech. I've been in Minnesota for the last 28 years. I have worked with university, private consulting firms, and for the last 15 years, I have been working with local Manitoba government. So majority of my work area is modeling, water quality monitoring, assessment, as well as communication and administration. So this is an absolute honor for me. I am the main coordinator for this tool. Houston Engineering is our, main folks working on this thing and helping us move it to the next level. So I appreciate the opportunity, Michelle and Jen, and I look forward to the participation. It's nice to see the survey results. That gives me, as I'm starting new in this position, like what level, when we see users, what kind of effort they need to make it more usable as well as helpful tool for their planning purposes.
All right, thank you, Uday. And just a couple more things on this slide to point out. I do have the links on the slide to where kind of PTMApp is housed within the Minnesota Board of Water and Soil Resources. I believe Jen with American Farmland Trust is going to be kind enough to drop those into the chat so people can live click on those and now or in the future if they'd like to figure out where that information sits. And just final thing by way of introduction, Uday mentioned this, Houston Engineering is a vendor. I want to make it very clear, we are a private company, but we do not own PTMApp. The intellectual property for it is owned by the state of Minnesota, and to date, and my understanding is into the future, it's going to be maintained as a public resource that is available for people to get at and use. And so you'll hear that as we move through the presentation here. Maybe a bit jarring as I move to the next slide, just quickly, Houston Engineering is about 250 employees. Our footprint is really in the upper Midwest. You see our office locations on the slide, but we do projects that take us nationwide. Reason I said jarring, you'll see that the template color changed, and I did that intentionally. This is a Houston template color. Remainder of the slides will kind of have this blue-green background to it. And I wanted to do that intentionally because this is more of a state of Minnesota template, and I'm really a steward of this presentation today as a vendor to the state of Minnesota. So I want to emphasize again, this is not Houston Engineering's tool or technology. I'm just here as a presenter on behalf of the state of Minnesota who maintains this for public access. Quickly, this is a bit of a presentation overview. First thing I'm going to be talking about on that first bullet is really history of the tool, kind of the purpose and why it was developed, and then just a brief overview on the methods. I'm not going to do a deep dive on the methods today, although when I get to the demo portion of my presentation, I do intend to show you where some of the documentation is for those methods. If anyone on here really likes to get into the weeds on the technical aspects of how the tool runs. Next, I will have a portion that really emphasizes kind of what are the uses for local practitioners. And this bullet will actually dovetail with the third bullet showing the example applications. For me, those kind of go hand in hand. So we'll talk a little bit about how this tool is being used by local practitioners and spend a good deal of time showing examples of how local practitioners have been using this tool to engage in conservation and water quality. Finally, and I put this in here intentionally, I know there's a survey that was conducted to kind of get attendee feedback on what they would want to learn or what type of questions they might have about this tool. So I did insert slides specific to those questions, which American Farmland Trust was nice enough to share with me before this. And then finally, the last thing I'll close on before I go to the demo is not listed on my bullets here, but I will be doing that, is a brief overview of the steps that are needed to adapt PTMApp to new geographies. As part of that, I'll be sharing, the geographies it's currently being used in that I'm aware of. But we will talk about, ability to adapt it to new geographies. One more quick acknowledgement as I move into this snapshot slide. I did see Matt Dreowitz's name on the attendee list. He works now with the Minnesota Pollution Control Agency in Minnesota. He used to be part of the Bowser team that was working on this with us. Just want to acknowledge that there are a number of slides in here that I believe he actually developed. So again, I'm serving as a steward for the state of Minnesota and building off of some of the great work that Minnesota Board of Water and Soil Resources is leading with this tool. For those of you who've attended past presentations through this American Farmland Trust series, I think these snapshot slides might look familiar. So I adapted some information on PTMApp into a 2-slide table here that we'll be going through that is just kind of a snapshot of information connected to the tool. Hopefully it'll give you a little bit of continuity with some of the other presentations you've maybe sat in on. So just quickly working through this scale and level of specificity of PTMApp, and I'll be demonstrating this with some examples as we move through. It was really set up to work at multiple scales, everything from the field level up to, at least this is the practical limit, a Huck 8 watershed. And when I say Huck 8, I'm guessing a lot of our people on the call are familiar with that term, but that's referring to the USGS Hydrologic Unit Code Huck 8 watershed. Outcomes that can be modeled with PTMApp. The core tool is really focused on water quality loss reductions, specifically reductions in sediment, total phosphorus, and total nitrogen. So figuring out where those three constituents are coming from and what the opportunities are to reduce those constituents from surface waters. The conservation practices that are accounted for by PTMApp, I have them listed here. I'm not going to go through them one by one. You'll see a little bit more of this in the demo and as we work through. But big picture of these 21 different practices, what we did is align them to the best of our ability with NRCS design standards. So I'm sure many on the call are familiar with the Field Office Technical Guide. In getting the tool to recognize these, we looked at the Field Office Technical Guide and did our best to get the tool to replicate components of the Field Office Technical Guide recommendations from NRCS on where these can be placed. Land use and production systems. I'll say on the slide here, in theory, PTMApp is adaptable to most landscapes in the continental United States. And you'll see as we go further into the presentation, even outside of the continental United States. However, it was really designed to focus on production systems with a primary emphasis on row crop and pasture lands. So that's the bread and butter, so to speak, of where it's been used, and what it's been used for is cultivated system, pasture lands. But with the way the system is designed, I think it could be adapted to a broader suite of land uses, particularly if that land use is in the National Land Cover data set. States and territories where it's being used, that we're aware of, it has currently been deployed in Minnesota, North Dakota, Iowa, Wisconsin, north of our United States border in Manitoba, that's the MB, and then on the island of Oahu in Hawaii. I do have in bold text, I would say it's available everywhere. So if you're familiar with water quality and have at least a moderate level of GIS expertise, it's a public toolbar that goes in GIS. You could access it and adapt it to your location as well too. But these are the known locations where it's been successfully run. How much time and data and skill needed to generate it? This is kind of the way I'd categorize it. The entire system for coming up with your data is built into ArcGIS. You need a moderate level of GIS expertise to develop the inputs needed to run the tool. Running the tool, I'd say really just a novice GIS user, and this will be in my demo at the end, just clicking through the buttons and getting your outputs. And then using the outputs, this is where we go back to a moderate level of GIS expertise. This GIS toolbar does generate a lot of data, and you got to be fairly familiar with GIS and being able to do kind of one-to-many table joins, pulling in shape files and raster data and all kinds of information in GIS to kind of connect the dots and get the information you need. Special note, at the end of the day, really, the intention of this system when it was built was to provide broader access to water quality modeling information to people who needed it to track progress towards surface water quality goals. And I think you'll see that as we go through the demo, that's kind of what the intent is. And I think at least within Minnesota, that purpose and vision, so to speak, has been achieved. So just quickly on strengths and limitations of what PTMApp does pretty well, and maybe where it's not as strong. I think some of the strengths on the left side of the slide, it is publicly available. The state of Minnesota, at least to date, and is showing signs into the future as well too, is going to continue to support this as a resource that's available publicly. Users do have a lot of discretion once you get the results to use it at multiple scales. Again, I think that's another strength. When you get the output data, you're not just restricted to a big watershed or a small watershed or a field scale. You have a GIS database that can help you with water quality issues at multiple scales. It does support planning and implementation. And this is a question we'll spend a little more time on at the end of the presentation here, showing some examples. It has been demonstrated to be able to support at least portions of the information needed for a federal 9-step plan. Some of the limitations, it is largely empirical. So we use a lot of PTMApp is built upon assumptions and research and empirical data. This one I'll explain in just a little more detail, doesn't speciate nutrients. So for total phosphorus and total nitrogen, you cannot subdivide that into components of being dissolved or attached to sediment, etc. It gives you just total phosphorus, total nitrogen, and sediment erosion on an annual basis. So that is a bit of a weakness. Some other models can provide a little more detail on that. In terms of being able to do it, setting up the inputs in particular does require a moderate level of GIS expertise. So there is a bit of a lift there. And thinking about the broader United States, although I feel pretty confident in saying it could be used across the United States, to date, it really has only been adapted in a few states and a few regions. So that is a limitation, because there is still a lift there if people, say, for instance, in Utah wanted to start using this. To the best of my knowledge, that hasn't been done yet, and there would be a bit of a lift in doing so. So switching more kind of in purpose and why this tool exists. In the state of Minnesota, we have something called the Clean Water Fund. So we decided years ago to tax ourselves, and a portion of that tax goes into something called the Clean Water Fund, which on average is about $90 million a year in our state of state-based tax money to spend on improving water quality. Because of that, the state of Minnesota, our legislature took a position that we need some accountability for how this money is being spent, and they passed legislation to that effect. And that's really what drove the development of PTMApp. And really what I think people were looking for was a shift from counting widgets to tracking progress towards environmental outcomes. And what I mean by that, when I say widgets, is, to me, counting widgets is, number of practices, acres of practices. Whereas shifting towards environmental outcomes is really saying, what water quality benefit do those practices have to a resource? And so you're seeing an example here in the bottom right-hand corner of goals that were set by PTMApp that local governments are tracking towards using PTMApp as a tool. And I'm not going to spend any more time on that example right now. We're going to come back to it in just a few slides with a little more detail. So I mentioned we'd spend a little more time talking about scale. And this one went kind of hand in hand in our state with being able to track towards environmental outcomes. The tool needed to be flexible to do that at multiple scales. We developed local government watershed plans at about a Huc-8 scale. So this tool needed to produce information that could support those local government watershed planning processes. But as those groups got into implementing their work, ramping up conservation in those watersheds, it needed to be flexible to address goals and surface waters at multiple scales and move kind of up and down what you're seeing here. And even when a conservation practice gets put on an individual field, provide a calculation that'll roll back up to those broader watershed goals that were sent through those local government planning processes. So that is, that was a core need. In addition to be able to track towards water quality outcomes, there was also a need for our groups inside of Minnesota that led to the development of this toolbar to track at multiple scales and use at multiple scales. And so that's where kind of the need and the purpose behind why PTMApp got developed. Now, I keep just saying PTMApp, but there's really two components to this. There's a desktop component, which is a toolbar that can be installed inside of ArcGIS. And again, I have another link here. I'll show you where that is. If you use the parent link from earlier in the presentation, and I'll show you how to do this, you can get to this link as well too. But in addition to the desktop component, there is a web component. Simple way to think about this, the desktop is standalone. You can run that, get the data, use the data. Inside of Minnesota, at least, the website is something that can take advantage of that data once it is produced to make it easier for the user to interact with. However, this website is really only stood up for the near term in Minnesota, and the state of Minnesota's agreement with North Dakota. So the website's also available in North Dakota. It would be a bigger lift to stand up this website. So I'm not going to spend as much time today talking about PTMApp web. The bulk of what you're seeing in the presentation is going to be focused on PTMApp desktop, which is the analysis engine that would allow users across the United States potentially to have access to this tool and use the outputs. So just acknowledging history of this system coming together, there is a long history that led up to the state of Minnesota deciding to develop this toolbar. You're seeing kind of the process of that. It really started in our Red River Basin, which is kind of northwestern Minnesota. That's where some of the groundwork was laid through multiple efforts led largely by the International Water Institute and the Red River Watershed Management Board to develop some techniques using GIS that we were able to build off of for PTMApp. At this point, though, we launched, and this would have been about 2013 to 2014, from the final bullet here into the PTMApp system. This is showing you an overview of the inputs needed to run PTMApp desktop. So the table on the left side are the inputs that would need to be developed in order to run PTMApp. And the reason I'm showing this, if someone on the call is interested in running PTMApp, this is where the bulk of the energy goes into having to do it. So if you think about kind of rough percentage of effort needed to get to output data with PTMApp, I would say 80% of the effort is in developing these inputs, 10 to 15% in running the tool, and then another 5 to 10% in doing common sense checks to make sure your results make sense. So this was an important slide in my mind to share, to just show the information that's being used. Kind of one of the real keys and the biggest part of the effort in developing these inputs is a digital elevation model that has been hydro-conditioned to represent where surface water flows. I think most all of PTMApp runs to date have been done on top of a digital elevation model that was derived from LiDAR data. So that is really an important input. In theory, PTMApp could be run in places where you don't have LiDAR data. However, to get at that multi-scale analysis, especially going down to the field scale, it's pretty important to be able to have this digital elevation model derived from LiDAR data. So again, I just wanted to call that out as a key input. I think the rest of these things probably pretty self-explanatory to most on the call. Surgo is the NRCS soils data. Curve number is pretty self-explanatory from hydrologic theory if you get a background in that. The suite of elevation products, inputs for the Russell calculation for soil erosion. One unique thing, and there's a second tool available that can help users generate this, is a travel time grid. And we'll get into this in just a minute, but the bulk of PTMApp calculations are connected to assumptions around travel time of water. So with that, I think I'm transitioning next into a little bit of a background on methods. As I mentioned, I'm not going to go over in depth all of the methods inside of PTMApp. I'm just going to show kind of one of the unique things that PTMApp does to estimate the benefits of conservation practices for reducing sediment, total nitrogen, total phosphorus. As a lead into that, just briefly, PTMApp is driven by a Russell calculation for soil loss, and then empirical estimates of total nitrogen and total phosphorus yield for different land use categories. And the land use categories that are embedded in PTMApp are driven by the National Land Cover data set. Users have the ability to change those, but that's the background on how it's set up. To go from the loss of sediment, total phosphorus or total nitrogen, to an impact on a downstream water, we use the time of water travel and some simple empirical decay equations to get at how much of the phosphorus, sediment, and nitrogen goes from a field to a downstream river or lake. All right, this quick overview. I'll show you where to get the details on those methods later in the slide and the demonstrations here. So one of the unique things PTMApp does though, and I wanted to highlight, is it actually fluctuates the efficiency of a practice, how much it would treat based upon where it's at on the landscape and how much water it sees for a design storm event. So what we do for every practice, we look at how much water would get delivered to it at that point on the landscape, either in velocity or volume. I'm showing velocity on the screen here for grassed waterways as an example. And then we also calculate the treatment potential of that practice on the landscape. So how much water it can treat. And we take a ratio of those two things. So a ratio of the water delivered to how much it has the capacity to treat. And we use this to adjust how effective that practice would be in treating sediment, phosphorus, and nitrogen. The idea being, there are places on the landscape where you could put a conservation practice where it would see too much water and wouldn't be as efficient in treating sediment and nutrients. So we call that a reduction ratio, and showing here graphically what that looks like for these practices. And as you can see, there's some some potential practice locations here where they'd probably see too much water to be effective in treating that water. What we then do is take that ratio along with empirical information on how effective those practices are. So we go to the research, and for a grass waterway, for example, we look at the distribution of how efficient research suggests that practice is at treating sediment and nutrients. We then use that research to bound how effective the practice is going to be in the PTMApp data in reducing sediment and nutrients. And you're kind of just seeing a graphical representation of that, where we go from the reduction ratio, we incorporate that in with the decay function that is driven by research on that practice to show how efficient the practice will be at various points in the landscape and treating, in this example, sediment. In the background, it does it for nutrients as well, too. So again, that's a bit of a unique aspect of PTMApp, in my opinion. From what I've seen in a lot of water quality tools, more often than not, there's some static assumptions on how efficient the practice is. But in this instance, it actually varies based upon the amount of water that practice likely sees on the landscape. All right, so now we are transitioning in the slide presentation from background, history, and methods on the tool into how is the tool being used, what purposes it's being used for, and then after this slide, going into examples of those uses. So these are meant to be very broad buckets of how PTMApp is used for planning and implementation. So I'll go through these real quick, and then over the next several slides, I'll be showing some examples of where this is being done. And that's where early in the presentation, when I gave my overview bullets and I said that, how local practitioners are using it is going to kind of merge in with the examples being used of how it's being used. That's kind of where we're at now in the presentation. So these are the boxes that local practitioners are using it for. And then after this slide, we're going to be transitioning into examples that demonstrate these uses. So in the planning bucket, really what the drivers are in planning, and I mentioned the local government watershed plans that are done in Minnesota, is for setting priorities areas in a watershed to do work, developing implementation scenarios for what types of practices fit where. And this includes a few components. It includes setting goals for water quality and how much progress can be made towards those goals during a plan implementation period. So again, for example, if you have a lake that is impacted by too much phosphorus loading from a watershed, PTMApp could give you an estimate of how much phosphorus is being delivered to that lake. And then you could use potential conservation practices to get a sense of, in a 10-year period, for example, how much progress could we make towards improving that lake and reducing phosphorus delivery. And that dovetails into in addition to developing implementation scenarios, you can evaluate them. So if we do X amount of conservation on the landscape, how close are we going to get towards those water quality goals? Now, during the implementation of conservation, how PTMApp can be used, so we're switching from planning to implementation, it can be used to help prioritize specific fields that would be better opportunities for conservation based upon water quality benefits. It can be used to evaluate the water quality benefits of individual conservation practices or groups of conservation practices. And then finally, and I think this is turning into one of the more common uses in Minnesota, and I'll have some examples of this. Once a plan is in place and you start, the boots are on the ground and you're getting conservation put in place, PTMApp can be used as a tool that tracks progress towards the goal in plans over time. So first example here, setting priority areas. I'm showing an example of what I'd refer to as a source assessment. The map on the screen is showing sediment yield in tons per acre per year. Apologize, I did not have year in the legend label. And the darker brown indicates areas on the landscape that yield higher amounts of sediment. So the idea being here, if you were working in an area where you needed to reduce the amount of sediment leaving the landscape, the darker brown areas might be a good area to start focusing. Now, not shown on this slide is phosphorus or nitrogen. PTMApp can do the same source of assessments for both of those nutrient types. In addition, what you're seeing on the slide is really indicating how much sediment gets to the edge of the individual polygon that you're seeing, the individual blob. We consider that the edge of the field or the edge of the catchment. You notice these green dots on the map on the bottom of the screen. PTMApp can also help to identify how much sediment or nutrients from these same blobs would arrive at those downstream dots. So in this instance, that's a major stream outlet, could be a lake. So that's where you can transition from, numbers in the field to how what's going on in the field would benefit a downstream resource. I mentioned also, and this is, as I said, becoming one of the more popular uses of PTMApp is tracking progress towards water quality goals. You saw this figure in the upper left-hand corner earlier in the presentation. This is from the Wild Rice River in northwestern Minnesota. And this PTMApp was used in a tool to develop their local water quality plan. And what you're seeing is examples in that plan for goals that they set. And so within this planning area, they set goals for reducing sediment by 9,322 tons per year at the edge of a field or at the edge of catchment. Similarly, at the edge of the field or edge of catchment, they wanted to reduce phosphorus by roughly 1,500 pounds per year. And then they had a couple of ancillary goals as well, too, connected to water quality and land protection. Talking about the water quality goals, though, as they now are implementing their plan and they're ramping up the implementation of conservation in this watershed, they are periodically using PTMApp to calculate back against their progress towards achieving these goals. So that is, I'd say in Minnesota, one of the most common ongoing uses of PTMApp. First setting this goal, and then over time, as conservation gets put on the landscape, tracking progress towards achieving it. As part of planning processes, I mentioned the development of implementation scenarios, so it's also a tool that can be used for that. If you're not familiar with the Minnesota area, on the screen I have Mille Lacs Lake shown. This is a rather large freshwater lake in central Minnesota. It's kind of an iconic walleye fishery in our state. And so PTMApp was used in this instance to help estimate how much conservation would be needed to achieve phosphorus protection goals for Mille Lacs Lake. So Mille Lacs Lake is still fairly clean. They are concerned about extra phosphorus being contributed into the lake over time. PTMApp was used as a tool to help with that. And I use the word they. Who I'm referring to in this instance is the Mille Lacs Band of Ojibwe. So this was a Native American tribe, First Nations people, who were working through a non-point source plan connected to 319 processes in the state of Minnesota. And so PTMApp was an underlying tool that was able to help them think through what amount of conservation would be needed to make progress towards those non-point source pollution goals for this lake. Next, and this is transitioning just a little bit. I hadn't mentioned this yet in the presentation, I don't think. One of the newer things that's coming online for PTMApp is the ability to look at hydrology as well as water quality. And I just wanted a quick example to highlight this and also show PTMApp's use outside of Minnesota. So this is for Dubuque County, Iowa. So kind of the northeastern portion of Iowa, if you're not familiar with the geography. They were working on a process to target conservation for both water quality and quantity benefits. And so there's an adaptation to PTMApp that was developed in the background that would allow you to look at both water quality and quantity. The next slide I'll show in a little more detail what that looks like. But what they tried to achieve here was a couple of things. They wanted to rank Huck 12 watersheds across the county for their ability to make progress towards water quality and quantity goals. So you're seeing that in the upper left-hand corner here, darker green, indicating areas that were more conducive to that. In the center of the screen, you're seeing a zoomed in version of the data that was underneath that heat map in dark green that's showing top 100 practices in a Huck 12 watershed that was a priority for implementation. And what PTMApp was able to do for these top 100 practices that were weighted based upon co-benefits of water quality and quantity was to estimate how much progress for a given investment could be made towards nutrient reduction goals, as well as reducing peak flow at the outlet of this HUC-12 watershed. In this instance, the top 100 practices were estimated to be able to provide a 55% peak flow reduction for a 10-year, 24-hour storm event. And so just showing this in a little more granular information and kind of the underlying data that can be used once that hydrology add-in is adapted to the PTMAP data. Showing central Minnesota now again. In this instance, you're just seeing an example for a small conservation implementation strategy for storage practices, how the hydrograph could be influenced by implementing those conservation practices. And showing this as one, the change in the hydrograph for 3 design storm events, as well as what particular areas in the landscape would see that reduction in various portions, showing again those catchment boundaries. Information on this technique has been developed. It's been tested in multiple watersheds. The state of Minnesota is in the middle of a process to turn this into a publicly available add-on to PTMAP. What that means, you have your PTMAP base information completed for water quality. Once this tool is available, you'll be able to pick that information up and now run kind of like a mini HEC HMS model on top of that, if you're familiar with HMS. And another example, going now down to the field scale. This is an example of where we did field scale analysis of the water quality benefits of conservation practices. In Minnesota, we have something called the buffer law. It requires landowners on public waters to have a 50-foot buffer for rivers and streams. It has a kind of a sub-bullet that says you need to do the buffer or alternative conservation that provides a water quality benefit equal to or greater than that regulatory 50-foot buffer. So we had a landowner that came to us and wanted to know if the conservation he currently had on his field would satisfy the requirements of that buffer law. So we used PTMAP to do an assessment on a 50-foot buffer around the public water running through his field. We then also worked with him to get information on the conservation he had on his field. Again, use PTMAP to assess that from a water quality benefit perspective. And we're able to show that in this instance, this field was a conservation award winner, so it was a no-brainer to test this. Had plenty of conservation on the field to be compliant with the buffer law, as the existing conservation far exceeded the sediment reduction potential of what the buffer would have provided. In addition, I mean, the landowner, had he chosen, could have evaluated some proposed new practices as well too. And that's being shown on the right side of the screen, or expansion of the existing practices. All right, one more example here of how it's being used outside of Minnesota. I'm about to trip over to my demo here in just a minute. This is on the island of Oahu. And what I'm showing is an initial sub-watershed. This is called the Kayaka Bay watershed. So this is Kayaka Bay down here in the bottom left-hand corner. This is the area contributing to Kayaka Bay. The image here in the upper left-hand is an image looking up into the Kayaka Bay and showing an example of how this is actually right now, as we're speaking, in the process of being adapted to Oahu. I wanted to use this as an opportunity to address 2 of the questions that came through to PTMAP came through to Houston Engineering from the survey that was conducted previously. And those questions were, is it producer friendly? And is it being used outside of Minnesota? So the short answer is yes. I don't think you can get much further from Minnesota than the island of Oahu. And to answer the question of being producer friendly, we had the chance to go out there and work with Oahu Resource and Conservation District recently. So we're on the island, and we actually went and met with a rancher who is approximately in this area of the watershed. I'm not going to point exactly where, but we went out to their field and showed the map that's on the right-hand side of the screen here, and basically had the discussion of, does this connect with the way you see your operation working in terms of where there might be some issues and some opportunities for fixes. And the punchline there was the landowner was pretty surprised at how well it lined up with where things were on their farm and where there might be opportunities for additional conservation. So the answer to being producer friendly, I think it can be, And there's an opportunity to use this data to have some of those conversations between a conservation professional and a producer about opportunities. Next question we got back, and I think this was the third of three, was can it be used for 9-element watershed-based plans? I mentioned earlier in the slides that it can be. Here's just one example from West Central Minnesota, where it was used to satisfy portions of a 9-element plan for Whiskey Creek watershed inside of the Buffalo Red River watershed. And so through our Minnesota Pollution Control Agency is in charge of the 319 funding that comes down through the federal government in order to have access to that through one of our programs in Minnesota. The local governments need to have a 319 9-element plan developed, Section 319. So in this instance, you're just seeing a couple of the maps that PTMApp helped supported for that 319 plan. Now, it won't write the whole plan for you. There's a lot of information that goes into those 9-element plans, but it can be used to satisfy at least some of the portions required for that 9-element plan. I touched on this earlier, so these are the known geographies. Just recently in the last couple of weeks, so I didn't get it on the slide, we did learn that there is a professor in Oklahoma who is working to test PTMApp on some pilot watersheds. So that could get added to the list here in the near future. And I did want to, before I jump over the demo, just touch on this quickly. Bringing this to new geographies, and this is meant to kind of be an abbreviated description of the steps we would recommend you going through. First thing, and this to me is one of the most important steps, is to identify how the default inputs and assumptions in PTMApp need to be adapted to fit your new geography. And we already have 2 instances of doing this. We did it with support and collaboration for some partners in Canada. We developed an adaptation memo for the province of Manitoba. So in that instance, not only changing some of the assumptions, but connecting Canadian data sets to United States data sets. And finally, and this is still a work in progress, we're in the middle of this project, we've come up with a guide for how to adapt inputs and assumptions to the island of Oahu. So that's really step 1, is going through a process where you go through all those inputs, all your assumptions that can be changed, and decide how you're going to change those. And then the next biggest lift I mentioned earlier, I would say, is getting that hydrologically conditioned digital elevation model. I'd say getting those 2 things done is going to be about 75% of your lift. In my mind, feasibly, that's probably a 3 to 6 month process to go through those same steps, or those steps. But once you have them in place, running PTMApp becomes something that's like a 1 month process. So it can go pretty quick once you get some of those first steps in place. All right, I'm moving over to the demo now. Just looking for feedback from American Farmland Trust. Did you want any pause in between the demo and the presentation, or should we wait to the end for questions? I apologize, I missed that part.
No, that's fine. Thank you. Typically, we just encourage people to write questions as they come to mind, and you'll take them during the discussion session. So just go on ahead.
Perfect.
Don't be shy with your questions and comments in the Q&A feature.
Thank you, Michelle. And so I set the demo up in 2 ways. The bulk of it is going to be walking through the actual buttons in the desktop toolbar and describing what each button does. So if you are a user and you start to use this, you'll have a sense of what's coming. That part of the demo is all going to be PowerPoint slides, because I did not want to risk ArcGIS crashing on me in a live demonstration. Then if I have time, I'm actually going to bring up PTMApp Web quick, just so I can show what that looks like visually and how users can interact with the data. In that, I'll also show you what that website link that was posted in the chat will reveal and kind of where to find stuff. So the first module, and what you'll see, each of these drop-down buttons that we'll be walking through, I'm going to call a module. And inside of each module is either one or several buttons you need to click. The first module is the ingest data module. And so broadly what this does is it takes your data that might not fit your study area, it clips it down to that study area, and then it runs some pre-processing routines that are needed to move through the rest of the modules. So the 2 keys there would be downstream flow length and upstream flow length. Those are the major processes inside of the pre-processing data button in the ingest data module. The next module is called catchment and loading, and this one has a lot of processing that it does. The key outcomes when you get done with this is it generates those field scale catchments. Those are, think of them as a unique watershed delineation at the field scale. So when you get the output, they average in size of about 40 acres to give you a sense of how small they are. And they're kind of the fine scale summary unit that comes out of PTMApp. So a lot of the information on nutrients and conservation practices does end up getting attached to these catchments for making maps and informing decisions. In addition, inside of this module, catchments and loading, you do your routines that process how much sediment and nutrients is being lost from the landscape and delivered to downstream resources. I'm going to pause there just quickly, and I keep saying this phrase, downstream resources. PTMApp also allows users to define what those downstream resources are. So what you do as a user is you put in points. Those points then are where you get summary information about the delivery and reduction of sediment and nutrients. And the users get to define those. Typically what users do is they're kind of major stream segments, stream confluences, or potentially lakes that people are working on within their geography, or potentially geopolitical boundaries if the entity performing the work has some obligation to a load reduction at a geopolitical boundary. In addition, one of the things, there are two things in here that are optional. I just want to call these out real quick. PTMApp has a routine for what we call lakes routing. So in Minnesota, we have a lot of lakes. There are certainly other areas in the United States that have a lot of lakes as well. And they do impact how much sediment and nutrients that enter the lake move downstream to other rivers or surface waters. So PTMApp has an optional routine if you're working in an area where you can account for how much lakes are impacting water quality in that study area. It also has a routine that will allow you to scale the loads delivered downstream. So as I mentioned several times, PTMApp is empirical in how it generates loading information. The reason scale loads was put into here is there was areas in Minnesota that had either or both long-term water quality modeling or potentially a heavy investment in a calibrated model like HSPF or SWOT. We wanted the GIS-based results of PTMApp to be able to be aligned with that data from maybe a more trusted data source, like a gauge or a calibrated model. So PTMApp does have routines that allow you to scale the information coming out of it to a more trusted data source. And so this is just a graphical map showing kind of the data you could expect to see once you complete this module, similar to the source assessment map I had earlier in the presentation. And that's the gist of, thinking about the products you can develop and assessments you can perform after you're done with this module. You'd be at the stage where you could do something like a source assessment for phosphorus, nitrogen, sediment. And just quickly showing the difference here for a one small watershed. Whoop, wrong button. There it is. This is showing load delivery of total phosphorus to the edge of a catchment or edge of the field. Clicking forward one. This is if you have the same data, same location, but show a heat map for delivery to a downstream resource point. In this instance, it's point number 3 here on the map that I made the map for. So again, deeper reds in this instance, or maroons, whatever color we want to call that, show a higher delivery of phosphorus to that outlet point of the subwatershed. Next module is the ranking module. And if I'm being honest, this one doesn't get used a lot, but what it does is provide a qualitative, normalized rank of the loading information. So it takes the mass of sediment and nutrients delivered downstream, and it normalizes it from 0 to 100% to show on a percentage basis which areas of the landscape are the highest contributors of sediment and nutrients. And so when you get through with this module, your source assessment information will be ranked in a percentage basis. And again, just showing an example of that for a new area in Minnesota where total phosphorus delivery to a catchment outlet is being shown instead of an absolute mass or pounds per year of phosphorus, is being shown on a percentage basis, with the darker reds having a higher contribution of total phosphorus. Just a quick note of another product that's inside a PTMApp. I didn't touch on this yet. Stream Power Index. So I'm showing here the Stream Power Index. I'm guessing some on the call are probably familiar with this. But what it is it's a ratio of the contributing area to a point on the landscape along with the slope of that point on the landscape. The idea being if you have a large contributing area and a high slope, you're likely going to have a higher stream power, which could result in issues with erosion. So this raster file actually gets used a fair amount in Minnesota to think about areas where you might have ephemeral gully formation or concentrated areas of erosion that you would want to treat with a conservation practice. Here, the deep reds are a higher stream power index, and as you scale back in color, lower stream power index. Next button is BMP suitability. So this button uses the GIS data, or this module, to find the areas on the landscape that might be suitable for conservation practices. And you're seeing on the left here a display of what that button looks like when you click it. By default, it will run all of the conservation practices that are set up inside a PTMApp for analysis. By unchecking these boxes, users have the ability to just focus on a subset or all the way down to one, grouping. And one of the things I'll mention here, there's two other buttons inside of BMP suitability. The main one is the delineation of those areas that could provide conservation practices. There's another one that if you're doing something like a water quality plan and you know there's an area of the landscape you're not going to work in, you can actually exclude those areas from the analysis. And finally, I apologize for the additional acronym here, but some of you may have heard of a tool called the Agricultural Conservation Planning Framework, or ACPF. It was developed by the USDA. It's something that gets used fairly frequently kind of in the Iowa, Minnesota area and other areas also across the nation. The core deliverable out of ACPF is the delineation of areas for conservation. So very similar to BMP suitability. But historically, ACPF didn't have any information on water quality benefits of those locations for conservation. So we've added an ability, if you have both PTMApp data and ACPF data, PTMApp will actually ingest those conservation areas and attach water quality benefits to them, consistent with the methods from PTMApp. So this is a map of BMP suitability output. I'm fairly certain, well, my legend didn't make it in here, I apologize. These are areas that I think PTMApp identified as suitable for cover crops. And this is in far northwestern Minnesota. So next one, benefits analysis module. So up until this point, just quick recap in the demo, we've come up with the data to do a source assessment. We've come up with the areas on the landscape where conservation can be placed. The benefits analysis module now slams those together. And for each conservation practice, it gives you an estimated load reduction benefit of that practice for sediment and nutrients. And so you're seeing the series of buttons you need to go through to get to that point. Starting at the top is that reduction ratio that I mentioned, that ratio of water delivered to a practice to what it can treat. Reduction efficiency then is the step where the reduction ratio is used to assign a reduction efficiency to each practice. And then the remaining buttons are the process of attaching the loading to that practice to the location on the landscape and estimating how much that load gets reduced. So at the end of this module, inside of your database, you'll have both the practice locations as a polygon shapefile and tables that you can connect to those practices that show what the load reduction benefits are of the practice. On the map, I'm just showing sediment reduction at the catchment outlet for a series of potential practices on this landscape. Again, I believe here I did cover crops. Now, if you're wondering why the shape of these polygons doesn't fit what you would consider a standard shape of an agricultural field, because that's where it'd be implemented. Again, it's because the cutoffs for individual areas are driven by those catchment definitions inside of PTMAP. So again, all this is connected back to surface hydrology. Finally, and I don't think I'd mentioned cost at all yet in today's presentation, so I'm glad this slide is in here. The last button is cost analysis. In addition to load reduction benefits and source assessments, PTMAP also assigns a cost to every conservation practice. And there's two versions of what it does for that. One, and you're seeing the one on the screen here, is default values that are based upon 2022 EQIP payment schedules inside of Minnesota for each of those conservation practices. Now, users can change all of these. So you're seeing this interactive box. Users can, and in my experience, do frequently make adjustments to these costs. Say, for instance, if I'm working in northwestern Minnesota and I know that a water and sediment control basin typically runs about $8,000 instead of $4,500, it's as simple as making that change right here, switching the number, and it'll get applied to all your practices. The other thing that there is not adjustments for, in the background, it also generates a life cycle cost estimate that is based upon research done by the International Water Institute. So I believe there's a published paper on this point, at this point, that gives backgrounds on that method. So you get two cost estimates, kind of a unit cost estimate for implementing that practice, as well as the life cycle cost. And so again, just showing an example of some farm ponds and what that looks like. So that's the conclusion of my demo. I am going to pull up the website quickly. I think we're about into the Q&A session, so I'm not going to spend a ton of time on the website, but I did just want to give a quick tour of what those links were, the links that were provided. So I mentioned if anyone wants to do a deep dive into PTMAP methods documentations, if you go to that PTMAP Bowser State MN.US website, click on this documentation button, you'll get another pop-up. And this is all the theory and documentation background for PTMAP. It includes a deep dive document on the methods. It includes several memos on adjustments and tweaks that have been made over time. It's got user guides and help documents, as well as some training sessions on developing inputs, running the tool, and using the output data. So fairly comprehensive set of documentation for the tool. This is also where, if you're interested in getting the desktop toolbar, again, you go to this website, you click on PTMAP desktop, and this brings you to the downloads that the state has available. Over on the left here are the base PTMAP toolbars, and you see the ArcGIS versioning that is currently available. Next is PTMAP web. I think I got about 5 more minutes, and then we'll still have 20 minutes of Q&A. So I will jump into it just quickly so folks understand what the website looks like. And this is what I actually use to generate all the maps in the demo. So again, for context, the toolbar is available publicly everywhere. Anyone can get the ArcGIS toolbar and attempt to use it in their location or location of their choosing. Inside of Minnesota, once you've run the toolbar, the state provides this website as a place that the data can live. And the idea being that this website's a little easier for non-GIS experts to interact with the data. So there's an interactive mapping feature that'll allow you to develop those source assessment maps and BMP maps for the PTMAP data. So when I was going through my demo and you saw all the different shadings of red, I actually generated all those maps inside of PTMAP web. There's a table generator. And so this, for a non-GIS user, is a method that allows someone to go in and download all of the tabular data associated with PTMAP for a watershed. And then I'm just, in interest of time, I'm going to skip over to the scenario builder. Users also have a step-by-step guide for developing conservation implementation scenarios. So it takes you through selecting your watershed all the way to how you're going to target your conservation. And at the end of it, a user can download the data. And so I just wanted to show this so that if at some point someone, like, let's say down in Nebraska, decides to start to use this system and would be interested in an easier to interact with web interface, it encouraged them to reach out to Uday at Minnesota Board of Water and Soil Resources, who introduced himself at the start of the presentation, because there would be opportunities, I think, for areas outside of Minnesota to at least engage in a discussion with our state about the ability to adapt the code to their area for PTMAP web. And so that was a lot of information. I think I'm right on schedule for kicking over to Q&A. And with that, I will stop my presentation and open it up for questions.
That was great, Drew. Thank you. Oh, I would love that. I enjoy that so much. And if people want to see more of the live demo of either the desktop or the web app, they can, ask for that now. We do have a nice chunk of time and only 2 questions so far. So everybody else don't feel shy. Haley Summers, hopefully I said that right, asked, have you compared potential conservation practice locations from PTMAP and ACPF? I'm curious how closely they line up.
The short answer is yes. In Minnesota, that work has been done. There's a postdoc researcher who took that on as a research project. And I believe, and Matt Dreyowitz, if you're still on and you want to punch any information into the chat window, please feel free to do so, because Matt was working with the postdoc researcher. And I punchline, I think there is generally pretty good alignment between the 2 systems and where they predict conservation to go on the landscape. However, depending upon the individual conservation practice, there can be some differences. American Farmland Trust team, if you see Matt post anything different, just let me know.
Yes, and if Matt wants to let us know he wants to come off mute, we can also do that for him so he doesn't have to type too much. So Matt, just let us know. Nice to know you're on the phone, Matt. June Grabmeyer asks, are you using the equip payment rate or the payment schedule background data on practice costs?
That's a good question. I'm going to do my best to explain it, because I'm not, I got to admit, just sitting here today, I'm not familiar with what the difference is between those 2 things. We go into the line-by-line payment schedule for that NRCS practice type. We then pull out what we feel we can represent in GIS the best from that payment schedule from the NRCS. And again, the most recent update was from 2022 to align with that conservation practice. So caveat there, for something like a water and sediment control basin that might have multiple cost schedules that get used for calculating the cost of that practice, there's a bit of a disagreement there, right? Because we're only picking one. So in practice, what we've seen with the clients we've worked with this is we'll present them with that table and say, this is our single unit cost point that we could come up with that we felt might reflect and scale within GIS. If locally you have a better handle on what these practices are going to cost, or now that we're in 2023, almost 2024, you have a different rate schedule you're using, let's just change those before we hit go on the toolbar.
Great. Haley Arnold asks, so far the examples have been in agricultural areas. Has this tool been used for any urban areas?
Short answer, no. We haven't really focused on an urban only area with this tool. It has been largely deployed in agricultural areas. Now, in Oahu, actually, the second watershed we're going to deploy it on in Oahu. So I showed you Kayaka Bay, which is on kind of the western end of the Oahu Island. On the northeastern end, the Waimanalo watershed is going to be our next watershed. In that area, we are going to have to grapple with low intensity development quite a bit with PTMAP. So I think in the next 4 to 9 months, we're going to have an example where we can at least have some understanding of how PTMAP performed in an area with a fair amount of low intensity development.
Cool. June had a follow-up and shared that NRCS does have a total practice cost estimate and applies a % rate, and the result is the payment rate. So if you use the payment schedules, it is only a cost share rate, not the total practice costs.
Correct. And that's where, so in practice, what's happened a lot, especially in these watershed plans, that's 100% correct. when we run those default assumptions, we'll show them the defaults, we'll show them the totals that come up with for the practice, and more often than not, they'll say, oh, that's only like 30 to 50% of what it actually costs to build that practice. And so they can leave it at that as kind of the cost share expense of getting the practice done. Or what happens more often in practice, they'll do something like say, let's double that cost, and that's going to get us closer to total cost. Now, I am interested in the total cost estimation technique you mentioned. So if that's something that you have a link to, you could share with us. Would be happy to share that with my colleagues at the Minnesota Board of Water and Soil Resources to consider as something we might look at in the future as adaptations are made to this toolbar.
Great, thank you. Martha McKean, Dixon, RCD, you talked about phosphorus as one constituent. Does this tool show nitrogen and or salinity?
No salinity. It only does total phosphorus, total nitrogen, and sediment. So it does not deal with salinity. I know in Minnesota, some of the things that come up every now and then is we have a lot of E. coli impairments. We're not working with bacteria with this system right now. I guess it's not out of the question to consider those in the future, but currently it is just sediment, total nitrogen, total phosphorus on an annual basis.
Very cool. We don't have any questions right now, but folks, just be brave, get them out there. One thing I wanted to follow up on was when you were showing the plan for, the goals for nitrogen, phosphorus, and sediment reduction, you mentioned, you used the words on a edge of field basis as well as or a catchment. Were you using those two terms to mean the same thing?
Correct, yeah. So when we present on this, I use those terms synonymously. Because we do not have field boundary definitions inside of PTMApp, it isn't truly an edge of field calculation. But those catchment definitions, those small drainage areas that average 40 acres in size, generally do and line up with what an edge of field number would be in most areas from our experience.
Got it. I'm used to seeing the word catchment associated with British English, which means watershed, not edge.
Yes, there are some jargon issues there for sure.
Okay, cool. Haley Summers writes, are feedlots or confined feeding operations considered in PTMApp? If so, how are those considered when thinking about nutrients or phosphorus loss?
Short answer is no, they are not. And I fully acknowledge that in many areas of the country, feedlots are something you need to grapple with when it comes to water quality goals, but that is not something that's considered inside of PTMApp right now.
Do you know of other tools that do have that as a feature?
I do think there are several water quality models that will attempt to incorporate that information as loading into their systems. I could be wrong on this because it's been a few years since I did a deep dive on it. For me, one of the things we've always struggled with when considering feedlots, and we did think about that with this system, is the exact locations of where they are within a watershed. I know for us in Minnesota, at least, we have databases that provide points of where permits are for feedlots, but they aren't always specific to the exact location of where that permit is. And the other thing we hear a lot is just because there is a permit doesn't mean that that feedlot is still active or has the number of head of cattle or livestock that are associated with the permit. So it's, for us, it was, with the level of geographic specificity in this tool, it was just maybe a bridge too far for us to get to.
And I don't need to keep us all here, but I actually had another question. If folks do want to click on the PTM desktop links, and what's the downloading experience that it would take? There were quite a number of links there. How long does it take to download? How much storage do you need to have? Assuming that you need to be a moderate GIS user, you may have a more powerful than average computer. already. What kind of, advice do you have for people if they get brave and try that desktop link?
Good
Serious
question.
advice.
And I'll answer the direct question on the desktop link, and then I'll go a little further into kind of typical database sizes for PTMApp, if that's okay.
Sure.
The desktop toolbar itself, I mean, we're talking seconds to minutes to download it and get it installed into your ArcGIS package. The toolbar itself isn't overly cumbersome to download. If you are in Minnesota and you go to that link, you can download some call them starter databases that have been developed across the state. Those are a little larger. I mean, there you're probably talking dozens of minutes to download some of the GIS data that could be used in Minnesota to help you get started with PTMApp. Now, if you make it all the way to running PTMApp in something like a Huck 8 watershed, I think you should anticipate between 30 to 50 gigabytes of space on your computer to accommodate the inputs and the output data.
Okay, that was really helpful. Thank you. And Matt Drewis of Minnesota Pollution Control Agency, thank you for writing. Minnesota has a tool for evaluating site-specific open lot feedlot fixes that University of Minnesota supports for many years and called MinFarm. So excellent resource there. Thank you. We have an anonymous attendee. What would be an approximate expected time commitment in terms of work hours for an experienced user to run PTMApp over a Huck 8 size area?
That's wow, work hours. That's getting pretty specific. I'd have to go back to I should do some quick math and try to get you an answer on that, because I think I got to guess. So for developing the inputs for an experienced user that has all the data available, I would estimate between 3 to 4 weeks of work time. The huge variable there is how much time you spend hydro conditioning your digital elevation model. So that's that process of manually putting lines into a digital elevation model to reflect where surface water goes. So if you do a fairly intensive amount of work on that watershed and preparing that, you're probably, 4 weeks is on the low end of what that would take, kind of conservative in the middle. But if you're not spending a ton of time doing that, your time to prepare inputs for PTMApp would be on the order of maybe 40 to 80 hours once you're experienced at it. From going from start to finish, the people time to run the tool is pretty minimal. Yeah, I mean, less than 40 hours to run the tool and check your data. And that's irrespective of the amount of time you put into the inputs. For a Huck 8 watershed, I would say there's a fair amount of computer time. So you could anticipate having your toolbar run over the course of a week through several steps that would have starts and stops. And I would bet once you're experienced, you'd have the tool running for about a week period, and your staff time would be on the order of 10 to 20 hours, depending upon the efficiency of your staff for running the tool and evaluating the outputs.
Great. That was excellent. Well, I can keep fishing for more questions, but I also know that people, have to get on with their day. And so I just want to give everybody an opportunity to say thank you to Drew for this excellent presentation. And I'll just show my screen for final follow-up, which really involves asking you to participate in that final survey opportunity. And hopefully you could be the winner of the gift card. So that would be fabulous if you did that. And remember, 6 p.m. is the time frame for that. And don't forget about that's the deadline. So get your answers in right now. Just join us December 6th for the AFT Retrospective Soil Health Economic Calculator Tool webinar. And if you'd like some free coaching sessions with us, I should tap Ross and I have done that for over 14 sets of organizations, and people seem pretty pleased with that conversation, and dialogue that we have to help them identify which of these tools that we're featuring on all of these webinars and in our report might be the right tool for their project. And of course, if you want a free copy of the guide, website. You can use those keywords there in your internet search engine, AFT Outcomes Tools, and get to a form that you fill out for a free copy. So keep in touch with us at that email. And I hope you all have a great day. And please provide survey feedback to Drew and to the next speaker and to us. Any more questions? I don't see. So thank you, Drew. Thank you, PTMApp, and thank you, Houston Engineering, for this great presentation.
Thank you, everyone.
Thank you, Uday. Bye-bye.